All right, let's start with number 13 here. Again, we're moving our way backwards. We went ahead and found out all of our factors of 136 and, or excuse me, our possible rational roots. So we have 1, 2, 4, and I believe 7 was another one. Let's see here, check the computer. I think we had 1, 4, 8, 17, 36, 68, and 136. Let's write these out here. 4, 8, 17, 36, 68, and 136. And all of these are going to be over our leading coefficient of 1. So we'll put plus and minus 1. When you go to the calculator, you're going to plug all of those into your L1 again. And then you're going to plug in your function into Y1. Then you're going to go to your home screen and you're going to go ahead and pull up again vars, Y vars, enter, 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 and parentheses L1, close parentheses, store in L2. And it looks like we have a 0, so I'm going to hit stat edit and find out where that 0 is, -4, and then scroll down to see if there's any others. And I believe it's just going to be -4 there. Yep, sure enough, it's going to be -4. So let's go back to our screen here, and I'm going to make a little bit of room. And we're going to have -4 as our synthetic divisor, so I'm going to have -4. And it's going to use all of these leading coefficients of 1, -2, 10, and 136, making sure that you're not missing any terms, and you don't need a 0. No, you don't. So let's get the first one for free. Multiply, then add, multiply, then add, multiply, and then add. So we went from a cubic down to a quadratic, and we're going to have this as our quadratic. We're going to plug into the quadratic formula. So I'm going to take -b, in this case +6, plus or minus the square root of b squared. B squared is going to be 36, minus 4ac, so 4 times a times c, all over 2a. A is 1 in this case. So this is going to simplify to 6 plus or minus the square root of 36 minus 136, which is going to be -100, all over 2. -100, the 100 is going to simplify to 10, the negative to I, so you're going to have 10i. 6 plus or minus 10i divided by 2, and yes, 2 does go into 6 and 10 for a simplification of 3 plus or minus 5i. And that's what the other two solutions are. These two right here and our synthetic divisor of -4. So our solutions, if you want to write this out separately, which I strongly suggest on your tests, are x equals -4 and 3 plus or minus 5i. Let's look at the rational root theorem. I'm going to go ahead and erase some of this previous work here to give us some more room. And they're simply asking us to go ahead and list all the possible rational roots. So to do that, I'm going to find out all of the factors of -8 over the factors of 1. This is pretty simple. You're going to have plus or minus 1, 2, 4, and 8 all over 1. So your possible rational roots are going to be positive or negative 1, 2, 4, and 8. That's all you have to do. They did not ask you to solve this. It says do not find actual roots, just find the possible rational roots, and that's all we did. Next one says use the synthetic division to find p of -2 for the polynomial p of x given here. Now, if you recall, you can find this by one of two ways. Using synthetic division, your synthetic divisor right here, to divide this and find the remainder, or if you remember the remainder theorem, it says simply plug in -2 in here and see what it spits out. So let's just go ahead and do that. -2 to the fourth minus 6, -2 to the third minus 2, -2 squared plus 7 times -2 plus 10. So let's see if we can simplify this. This is going to be positive 16. This is going to simplify to -8 times -6 for a positive 48. Whoops. This is going to be positive 4 times -2, so it's going to be -8. This is going to be -14 plus 10. So let's see if we can simplify this further. This is going to simplify to 40. So 40 plus 16 is going to be 56. Minus 14 plus 10, that's going to be -4. That's going to simplify to 52. That was our remainder, just by plugging it in. Or you could have simply divided this synthetically. I'm not going to do it, but to show you -2, you could have simplified or found the remainder by simply using synthetic division. Get the first one for free. Might as well show you how to do this. First one for free. That's a positive 1. It's going to be -2. Add -8. 16. Add 14. -2 times that is 28. -28. And that's going to be -21. And when you have, let's see, we're going to multiply this. That's going to be -2 times 21. That's going to be 42. Add, that's going to be 52, and it's going to be the same remainder. More synthetic division. We're going to divide this polynomial by this factor. So our synthetic divisor is going to be positive 2. Remember, you're going to still set this thing equal to 0. X minus 2 equals 0, so x is going to equal 2. And that's going to divide into -6, 18, -7, and then -10. Making sure we're not missing any terms. Let's move on. You get the first one for free, -6, multiply, add, multiply, add, multiply, and then add. So since we have a remainder of 0, you could say that x minus 2 is a factor. And you're going to be left with -6x squared plus 6x plus 5 as your leftover, or I should say your other factor for this polynomial. Divide again. We can do this the long way if you'd like. Let's go ahead and do x minus 2 and divide that into our polynomial, -3x cubed minus 2x squared minus x minus 2. So what times x gets you -3x cubed? -3x squared. Multiply that all the way through. Remember, this is regular division, so you're going to go ahead and subtract. -2x and -6x is going to be -8x squared. Bring down the next term. What times x gives you -8x squared? That's going to be -8x. Multiply that all the way through. And you're going to have -8x squared plus 16x. And remember, we're still subtracting because we're in regular division. And that's going to be -17x. Bring down the next term. Erase to make some space. And we're going to have what times x gives you -17x? Well, that's going to be -17. Multiply that all the way through. -17x plus 34. And you're going to have a remainder of 32. We said we were going to go ahead and skip number 8. let's find the real solutions of this equation by graphing. Let's bring up our graphing calculator, and lo and behold, it is a little bit defunct right now. So let's get this back to the Y screen, clear out anything we need to, and let's go ahead and put this into Y1 and this into Y2. So we're going to have negative 5x cubed minus 4x squared plus 10x. And we're going to make sure we got the x right there. I think I missed the x right here. There we go. And I think we needed to also plug in 0 here for y2. Then let's go to zoom 6 because that'll be a nice 10 by 10 by 10 by 10 graph, and find out where our two equations intersect. And it looks like they intersect here, here, and here. Second calc intersect to find them. Boy, these color calculators are a little slow. So let's find our first intersection point. Get your cursor to the one point of interest, and that is one point of interest right there. Enter, 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 and lo and behold, that's my first intersection. Let's do this again. Second calc intersect, and move our cursor over closer to the next point of interest. Somewhere about right there. And just hit enter, enter, enter. And it finds the second intersection point, our second value for x, negative 1.87-ish. And do that again, second calc intersect. And we need to go over to the other third spot. And hit enter, enter, enter. And we found our third intersection point. Let's keep moving here. What are the real imaginary solutions of the polynomial equation? Oh boy, we get to factor, don't we? So let's go ahead and factor this. What's being cubed here is 5x. Being cubed here is 7. A squared is 25x squared. A times b is going to be 35x. And b squared is going to be 49. Set this one right here equal to 0, and x is going to equal negative 7/5. Set this one to equal 0, not so easy. Let's go ahead and use the quadratic formula. So then we went ahead and plugged this into the quadratic formula and got all the way through where we got negative b plus or minus the square root of b squared minus 4ac all over 2a. Did some multiplying and some simplification you guys can use on your calculators. And I stopped at this point because some people have been kind of a little bit concerned about what to do with that negative. Remember, you always keep that negative out as an I, then find factors of 3675 that are perfect squares. And if you do a little bit of work, you'll find out that 25 and 49 are factors of this number. So I'm going to have 35 plus or minus I, kicked out the negative, 25 times 49 times 3 all over 50. Kick out the 25 as a 5, 49 as a 7. 7 times 5 is 35. So you're going to have 35 plus or minus 35i with the square root of 3 left over, all over 50. And if you divide 5 into all three of those terms, you'll be simplifying to 7 plus or minus 7i square root of 3 over 10. These are your other two solutions, and the other one was negative 5/7. Relative maximum and minimum, you're going to have to graph this one and find out your minimums and your maximums by doing second calc rel max. Find the zeros of the function. Well, that's going to be easy. Negative 3, 3, and 4. And numbers 1, 2, and 3 I think were relatively straightforward in factored form. Factor out an x, and then factor this little bunny right here. Last one here, last couple, is that we need to go ahead and divide this in here to see if it's a factor. And then the other one, what you're going to have to do is do some factoring and set each one of these equal to 0 to find the numbers of multiplicity. I think you guys understood those first two from today's review. Good luck, and I'll see you during test time.